Assalamu alaikum everyone. This is Mohammed Numan Islam Khan, and this is lecture 9 of our course, which is Numerical Methods. And just a quick overview of what we have done yet. Um, we have done our first topic, which was the approximate solution of the one variable equation. So we have learned the methods, namely bisection method, fixed point method, Newton's method, secant method, method of false position. So we have developed the iterative schemes of each of the method. We have seen that what are the criterias by which we will be able to get the solution with each of the method. Today, in this particular lecture, we will be trying to implement uh, the iterative scheme that we have developed for the methods I just mentioned into one of a programming language that we're using in this course, which is a MATLAB. Um, so in this particular lecture, we will be just visiting the basic commands of the MATLAB. We'll just try to make ourselves comfortable with the environment of the MATLAB, and then we will try to develop the pseudocode that already we have developed in the previous lectures of the bisection method. That was the first method that we learned about the solution of the one variable equation into the MATLAB. So let me just start this particular lecture with actually the pseudocode that we have already developed in the previous lecture of the bisection method. So our motivation will be clear that we wanted to actually implement this particular um, method into the MATLAB. Okay, and then I'll come to the definition, the basic definition or the MATLAB or basic command of the MATLAB. So let me just write over here what was the bisection method and what was actually the pseudocode that we have developed. So we have an equation which is f of x equals to 0. So it means that equation is obviously is an input parameter. Then we have an interval a to b, so where the solution lies. So that interval will also be an input that we wanted. And as we have seen in each of the method, in the approximate method, we need a certain accuracy to be achieved. So we call that with a variable in a short form TOL, which is a short for the tolerance. Okay. So these are the three things that are the inputs of our bisection method. Now coming about the output of the bisection method is obviously a real number p in this interval AB such that the absolute value of the function at this point p is less than tolerance. Okay, so if we wish to achieve a solution up to 10 to the power minus 4, so obviously a real number in this interval when we plug into the equation should give in terms of absolute value less than tolerance. Coming towards the process, what is the process of the bisection method? Hopefully you remember from the last lectures, we just do this is the step number 1 in the process. We find the central point of this interval, and then we check is this central point is a solution. So we have to repeatedly check it, and hopefully you remember that we use a while loop to check that condition, which is that the absolute value of the function at the central point we just find. If it is less than tolerance, then we need to stop. And if it is not less than tolerance, then we need to apply the bisection method. So it means if it is greater than equals to tolerance, then we have to apply the bisection method. Okay, what is the bisection method? We have written that if, for example, the solution lies between A and B, mathematically we can write like this, then we have to move obviously the variable B to the position P. Okay, else we have to move the variable A to the position B. Else means the solution lies between B and P. Okay, or P and B. Okay, so this is the end of the statement if, and obviously this particular half is outside the loop. So once the interval, the relevant subinterval is chosen where the solution lies, we need to half it again inside the loop. So let me take a half of the new interval, and I just end the while loop. So if you see, this is the body of the if statement inside the while loop, and this is actually the body of the loop that is performing the bisection method. So what we wanted maybe is that we can do this particular process into the MATLAB. Okay, so now coming to the MATLAB, so this will be our motivation, that in this particular lecture, after learning some basic commands of the MATLAB, we can implement the this particular set of operations that we have write in a very basic form. So coming to the MATLAB, this is the environment of the MATLAB. I just opened a MATLAB online. You can use this particular environment with your official accounts that NAST has provided you. So you can use MATLAB online, or you can just download it on your desktops or laptops. So whenever I just, let's just, I open a MATLAB, so there is a command window. So you see a cursor is being blinked into the command window. Okay, so here you see a cursor. So there are more windows over here. For example, if I go to this left panel, you'll see that I can actually, this is a command history. These are some files that I can open. Okay, so but at this point in time, I'm actually starting from the command window. Okay, so command window is a window where you are actually giving the commands. Okay, so let's try to have some basic idea of the MATLAB and then the basic command of the MATLAB. MATLAB, by the way, it is MATLAB stands for matrix laboratory. So we use matrices to actually deal with equations, algebraic equation, non-algebraic, or differential equation. Since matrices provide you a very sophisticated way to store the information. Okay, um, and MATLAB is a programming language. It is a programming language, and it is a case-sensitive language. So it means the small a and capital A are two different things. Okay, so let me just now start with some of the basic commands that we can write onto the MATLAB. Or you can also try on your laptops that you are using over here. Okay, and if you have any problem, we can just see it. So for example, let me write a is equals to 5. Okay, so if I write a is equals to 5, um, as you know in the programming, whenever you use an equality between the two things, equality sign, so the value has been assigned to the variable on the left hand side, okay, or whatever on the right hand side, the value will be, so a has been assigned a value 5. Now, since MATLAB try to understand everything in the matrices, so there are many built-in commands in MATLAB that we can readily use. We can also write functions that we wanted. So there is a command size. Size is a command that gives me the uh, order of the matrix, size of the matrix, how many rows it has, how many columns it has. So if I write size of A, you'll see it will give me an answer which is 1 1. So first index is actually telling me the number of rows, and the second index is telling me about the number of columns. So size command returns you a vector which in the first index contains rows, and then the second index contains the columns. So it says A is actually a matrix which contains one row and a one column. So you can think this way, that every real number is a 1 cross 1 matrix. Okay. Um, Now let's try to initialize a matrix which has more rows and more columns. Okay. So at this point I'm going to write initialize a matrix, maybe that you have already know the numbers inside the matrix. We wanted to write that. So let me write 1, 2, 3. So in the square brackets, um, I've just started writing 1, and then I press a space. So whenever you uses a space bar, it is the next element of the row. And if I plug a semicolon, it means I'm going to the next row. This is 2, 5, and 0, and 4 minus 2, 8. Okay. So, and this is the matrix I've just written, so I can enter it, and you see a display. Now in MATLAB, you cannot just go in a command window and rewrite things. For example, if I'm going to write the matrix and I made some mistake, so I can't just go into the command window and make the edits over here. Okay, what I can do is I can use the up and the down arrow key. So if I use an up arrow key, I'm just going to press the up arrow key. So you see certain commands in the command history are over there. So I can use any of the commands. So let me just reuse A. And for example, at the last index 8, I have to write a number 9. So I can make the changes at this point. I can have an updated value of the matrix A. So that is capital A. Okay. So that's how you can write the matrix, and hopefully you remember the command size. So now we have to write capital A because we want it. It's a case sensitive language, is it? It understands small and capital A as differently. Okay, so size of A returns you the order of the matrix, which is 3 rows and 3 columns. Okay, if you just use size and A comma 1, so it means it give you how many rows it has. Okay, and if I write A comma 2, so it will give you how many columns it has. Okay, by the way, in this case they are the same. If for example they are different, we can have an example. So for example, B is 1, 2, and 3. So we have 1 row and 3 column. So if I just call size A comma 1, so it will give me how many columns it has. And I just used A matrix. I have to do with B. Okay, so it's B comma. That's why I'm just worried why it's giving me. So I have to check with the B. So size of B is it has 1 row, and if I write size B2, so it will give me how many columns it has. So it has 3 columns. Okay, so that's how you can just extract the rows or columns, or you wanted to both information, you can do that. Okay, CLC is a command that you use to clear the command window. Okay, it will just clear the screen. It will not clear the variable that we're using. So we are using variable A. It's already over here. So if I just write A and enter, you'll see that variable. Um, Similarly, we're using other variables B and small a. Okay, so that's how you initialize a matrix, and that's how you're able to extract the order of the matrix. Now I'm coming towards a thing that, for example, in as you see a matrix A, so there is certain information is being stored in this matrix. So let's say we wanted to extract the information from this matrix. So what we can do is first thing, let's say we try to extract the information maybe at this position. So I wanted to extract this 0. So if you see this 0, it is in the second row and in the third column. So I have to write the position at which I wanted to access that particular position. So I'll write 2 in the small brackets with obviously matrix A 2 comma 3. You see, MATLAB tries to suggest you a possible command that you're using. Okay, so you can actually follow the information being provided. It can be helpful. So A2 comma 3, so it means second row and third column, so I can access the value 0. Okay, now for example I wanted to access um, the second row. I wanted all the elements in the second row. So what can I do is I can write over here. So the row position is 2, and in the column position, I'm using a sign which is a colon. I'm just using a colon point here at the column position. So it means I wanted a second row, and in at the column position, I wanted every column. So to write in every column, you can use this particular symbol. So if you just write this, second column will be extracted. Okay. Um, Now, for example, if I write like this, what do you think we're going to get? Anyone? Okay. Yeah, it will be the first column because at the row position you have put that sign which is a colon, and at the column position you mentioned a 1. So it is the first column. Okay, so you see a row has been extracted in a row vector and a column has been extracted in a column vector. Okay, now let's try to, let me just clear the screen. Let's see what A is. And now we try to extract, for example, I wanted 2 rows of a matrix, two particular sum rows. So what can I do is actually I can write like this. So there are two index obviously when I try to extract information from any particular matrix. So let's say I wanted to extract row number 1 and row number 2. Okay. So there are two indices, and the first index at the row I want 1 comma 2. So in the square brackets I'm going to write 1 comma 2. And at the column position, since I want all the elements of first and second row, so it means all the columns actually. So I'll write that particular line of the column. So if I press it, it will extract the rows that I've just mentioned. Okay, 1 and 2 in the square brackets at the row position. Okay, so similarly, you can mention any particular rows, any particular columns to extract the submatrix or relevant information from the given matrix. You consider matrix as something you have stored the information. Okay, so in view of the bisection method, maybe you have stored all the central points of the sequence. Okay, and in one of the column it is an iteration number. So at the first iteration number, this was the midpoint. At the second iteration number, this was the midpoint. So maybe you wanted to extract that information from the matrix. So obviously we need to know how to extract particular column, particular row, or a particular rows or columns. Okay. So with this, we will be able to extract the information from the matrix. Okay. Now I will come to some more basic commands. Okay. So first let me write I is equals to 1 colon 10. Okay. What do you think we're going to get? Uh, yes. Okay, so we're going to get numbers from 1 till 10. They are all being stored in I. Okay, so if you use a colon sign and there are two numbers, one is obvious here, one is smaller, one is a bigger number. So it will start from 1, which is a smaller number, and it will ends at the given last the ending point, which is 10 in this case, and with an increase of 1. Okay, so you increase a number by 1, so it is an increment of by 1 by default. And for example, if I just write the same statement but with another mm, a little bit change, so I just write start from 1, ends at 10 with an increase of 2. You see? Okay, so if you don't want a default increment, you can mention the increase. So it will start from 1, take a jump of 2, okay, from the first point, then obviously from the every previous points till the maximum number 10. Okay, so it will display like this. Okay, hopefully you remember from your programming course, this is something that you use in the for loops, especially the 1 to 10 command. That is, you try to run a loop for certain points, that how you can relate it to this information with that. Okay, so this that's how you can actually write the these particular commands. Make use of another column. Now let me just go to um, information we just have stored. One of the information is A, so there is a matrix. We have also written something in B. So you see B is a matrix which is 1, 2, 3. And let me just try to write, try to multiply B with A. Okay, so it is a multiplication of matrix B with a matrix A. Okay, now you see B has 1 row and 3 columns, and A has 3 rows, 3 columns. So resultant will be 1 cross 3. So in MATLAB, when you insert a multiplication sign, it means matrix multiplication. Okay, that's if you insert that sign, it can be matrix multiplication. Similarly, you can add the matrices and subtract the matrices. For that, the matrix should have the same size. And what different maybe is this. Let me just write another matrix C, which is 3, 0, and -1, for example. You just see here, I just matrix of C. What you see a difference, for example, with C and a B over here. Whenever I put a semicolon after the statement, that information will be processed, but it will not be displayed. Okay. So if you plug a semicolon after the statement, the information will not be stored. Okay. Now, why I've written C? Let me try to write B dot multiply C. So how this is different? And B and C have 1 row and a 3 column. Both the size of the matrix is same, but they are not compatible in terms of multiplying, because the rows of the B, which are 1, is not same as the column of the C, which is 3. So if I put a dot sign here, it means it will multiply term by term. Okay, a term by term multiplication. Each entry will be multiplied by the respective matrix, by the respective entry of the next matrix, which is written. So if I write B dot multiply C, so here 1 will be multiplied the B matrix with 3, 2 will multiply with 0, and 3 will be multiplied by -1. So that's how you can have, at times you wanted some operations to be like this in particular data. So you can use this command to multiply term by term. Okay. So this is another command that we can use. Okay, some special matrices that we can generate Or for example, I wanted a matrix of ones. Okay, so to generate a matrix of ones, what is a matrix of ones? A matrix of ones means each entry is one. Okay, so let me write a dimension of a matrix. I need 3 rows and 2 columns. For example, I need a matrix which has only entry as ones and they have 3 rows and 2 columns. Okay, so if you just write like this, it will generate a matrix of ones which has 3 rows and 2 columns. Okay, and there is another command which is it's called with the zeros. Okay, and then you just make an analogy with ones. So I want a zero in every entry. Okay, so I have to mention how many rows and how many columns. So let me just write three. I'm not going to write the columns. So at this point, matrix, the MATLAB will understand I have to generate a square matrix. So if you just enter one entry, then the rows will be same as the columns. So you'll get a matrix of 3 rows and 3 columns. Okay. Similarly, to generate an identity matrix, you can use the command EYE, and here you can write, for example, 4. So I'll get a 4 cross 4 identity matrix. Okay. Um, so these are some special matrices actually that we can have. And one more matrix that we at time will be requiring somewhere, it's matrix which is called a random matrix. So RAND is the command which used to generate a random matrix. The entries of the random matrix will be between 0 and 1. Okay, so I have to write the size. So let me, I wanted 3 rows and 4 columns. Okay, so first index is row, second is column. So I get a randomly generated matrix of the size uh, 3 and 4. Okay, so that's how I'm able to get any random matrix. Okay. Um, does anyone have a difficulty in the outputs that we are having? Maybe due to the lag of the internet, at times there may be a lag in terms of your outputs. Okay, you'll be hopefully you're getting things good. So this is some special matrices which are ones, zeros, random, and identity matrix. Okay, let me just clear the screen, and let me also use another command which is clear. Okay, so clear. If I write clear and space a, so it will clear the variable a from the workspace. What is the workspace? Workspace is whatever we actually using the variables that are being stored in a workspace. Okay, so now A is cleared from the workspace. If you check A, it will say, okay, this is unrecognized variable. Okay, and it said, did you mean A because small a is already in memory? So to remove all the variables, you can write clear all, or you can just write clear. Okay, it will clear all the variables being used in the workspace. Okay, now let me write a matrix which is A is equals to 1, 2, and 9, 0, 2, and 4, and minus 9, 0, and 3. Okay, just read it in the matrix A. And there is a command DIAG. So it's for the diagonal. For the diagonal, if you write matrix A with this command, it will extract the entries at the diagonal. So if you see at the main diagonal, we have the entries 1, 2, and 3. Okay, so you'll be able to extract the diagonal entries with this particular command. Okay, we can also generate a diagonal matrix with this command too. Okay, you can go check this with this command. Just write help, and any command that you wish to have its format, you can write it, It will give you the definition of that particular command with the how to use. It's a summarized way of that particular command. If you need its proper documentation, you can just open from here the documentation for this particular command, or you can just write doc and diag. So with this, you'll be able to see the complete documentation of this particular command. And one more command, which is to generate the linear spacing between two, for example, real numbers. So let me say I have a number 1 and I have a number 2. And in between 1 and 2, I wanted uh, total 6 linearly spaced points, okay, or equidistance points. So I want in total 6 points, including the endpoints, okay, which is 1 and 2. So I can use this command, which is for the to generate a linear spacing between 1 and 2. So you'll see I got total 6 points, start from 1 and ends at 2. Okay, so you can use this command to generate a linear spacing. Okay, for example, if I just recall this command and generate maybe 9 numbers, so it will generate total 9 numbers between 1 and 2. Now I will be coming towards some command that give me a solution of the polynomials. Okay, for that, let me just try to write um, a polynomial into the right over here, so you'll be able to understand it better. Okay, for example, we have a polynomial. Let me write that polynomial, which is 2x cubed minus 5x squared plus 8. Okay, and I maybe wanted to evaluate the polynomial at some point, that is at some value of x. For example, I wanted to evaluate p of 2, or maybe I wanted roots of these polynomials, means that where this polynomial is becoming 0. Okay, so what I can do is, let me just write in the coefficients of x cube. The coefficient of x cube is 2. The coefficient of x squared is minus 5. The coefficient of x is 0. And the coefficient is x power 0, which is the constant, 8. Okay. So this, if you write this vector into the MATLAB will also understand this as a polynomial. Okay. Now let's try to write the p, which is, so I'm just naming that as p. So it is 2 minus 5, 0, and 8. And let me use a command which is how to evaluate this particular vector, which can be understood as a polynomial at point 2. Okay, so if I just evaluate it, the answer is 4. Okay, so if you just write other than 2, you can write any particular number. So the MATLAB will understand the given vector as a polynomial if you use a polyvalue polyval command. We just use for the evaluation of the polynomial. And for example, if you want roots of the polynomial, you can use a command roots, and you can write that particular vector, which is p, and it will, the roots is just have given So it has two complex roots and one real root. So it has given you the roots of the polynomial, which is 2x cubed minus 5x squared plus 8 equals to 0. Okay, so that's how you can evaluate any polynomial in the MATLAB. Okay, so MATLAB will evaluate that particular polynomial, and it can also find the solution of the polynomial. Now, I will, since we will be just implementing in our mind, so these are some of the basic commands. Because once we are implementing the bisection method or any particular method that we have learned yet, you remember we have certain inputs, and there are a process, and then we have to have an output. Now, whenever we have an output, we need to display the output. Okay, so there are. So I'm going to now discuss how we can display an information. Okay, so there is a command display with which you can actually. What is the syntax? So, for example, let me write this is the bisection method program. Okay, so you can just display certain information to the user so that it is easily understood that what is being done over here, or any particular information that you can insert to display to the user. Okay, so you can use a display command, and then for example, if you wanted to display, maybe let me just write itr. So there is a variable itr which has a value 11. So consider it, for example, you got a solution through the bisection method in 11 iterations. Okay, so you can use our display command in a way that, so let me write over here. This is the uh, rather than this, just try to be more relatable. Sentence is bisection method. BM is just short form. Converges to solution in 11. So I wanted to write this, so I can write over here. So this is number to string. Okay, so I can use this command. Then I can just continue writing the iterations. Okay, so I can just close this. So now you will see that the information to user will be BM converges to solution in 11 iterations. So you can actually try to insert any of the variable numeric or a string numeric majorly. So you can do that with just modifying the display command. Okay, there is one other important command which is the fprintf. It's about how you display an information. Okay, so there is a command fprintf. Let me just go back. Let me just write, for example, a variable which is x is equals to pi. So how you access the value of the pi in MATLAB? You just write x is equal to pi in small. So it will access the value of the pi. So you see, this is a rounding up to 4 decimal places. Um, it's a rounding up to 4 decimal places. Um, the display is up to 4 decimal places. You see, okay. Um, if you, it's a by default display of the MATLAB. If, for example, you wanted a display which is more than 4 decimal places, you can have a format long, which will give you a display up to 15 decimal places. If you just again write the x is equals to pi, you'll see that it will give you a value up to 15 decimal places. That are 15 decimals after the decimal point, 15 um, integers. So this is about the format. Now we will be dealing comprehensively with this particular statement once we are going to implement the bisection method. Now let me just go to write actually the basic pseudocode actually we have developed for the bisection method into the MATLAB. You see, these are some commands which are multiples, obviously. So I can't do that in command window. I can have to write somewhere other than the command window. So I have to write multiple commands. So I can use from here. I can a new script. Okay, and let me just try to write the working that I have over here. Okay, let me see if I can actually. Okay, I can have a view of both the things for you, so we can maybe see the things in parallel. Okay, little bit maybe a visibility in terms of okay. So you see, this is the script I just opened, and I wanted to write in the script some things. Obviously, there are input. So let me start with the equation we are solving, which is x minus cos x. In that's why we take one example, so we know what is the solution. Excuse me. So we know the solution, which is 0.7391 of x minus cos x. So let me first write how to write a function into the MATLAB. Okay, so you can define a function. We learned in the basic command about the matrices and some things, but how to write an equation into the MATLAB. Okay, one of the way is I can write at the rate x. So it will tell, okay, I'm going to use the variable x and x minus cos x. Okay, so this is the value of f. Now the value of a is, hopefully you remember, it was 0, interval was 0 to 1. So b is 1. And let's say we wanted an accuracy, which is up to 10 to the power minus 4. Okay. And let me just go with the actually the by default format of the MATLAB. You can just write format just to make sure that uh, we are using the by default settings, and then we will improvise it, okay, as per our requirements. Now if I just write the process, if you see the process that is over here, okay, so it says we need to do the half. So let's do the half in line number 5. uh, I just actually entered just to have a difference between the inputs and the outputs. By the way, you can write over here any particular comment. For example, if I write inputs, okay, and maybe write over here from line number 5 over here. This is the main process actually. Okay, so if you write anything with the percentage sign, it will be considered as the comment. So p is equals to a plus p divided by 2. And now if you see while, so all the actually keywords in MATLAB are in small letters. So while space, and there is an absolute value of the of f at p. So for absolute we use ABS. Okay, ABS. F value at p, the equation value at p should be greater than or equals to tolerance to do the bisection method. Okay, if f of a, so I'm just trying to write the code actually we have developed by following the pattern of the bisection method. So if f of a is into a, f of b is less than b, then b is equals to b, then we have to move b, else we have to move a. Okay, then if I write end, so this is end of the if statement. Okay, now I'll write the statement which will do the half. It is this particular statement. Now I will end this. Now you see, I have put a semicolon after line number 2, 3, 5, and 9. Actually, and let me just write over here to make sure that we don't get confused. After 11, after 13. So whenever I put a semicolon, as I discussed in one of the commands in the command window, if you put a semicolon, that information will not be displayed. Okay, because whenever we're trying to solve the method, an equation, user wanted its solution. Okay, so we don't want to show it the process, how the process is being happened, what are the values which are being changed. Okay, so we want a show at this point, maybe just a solution to the user. Okay, so we can just put the semicolon after that. Um, Okay, okay. Um, okay, why not after the line 7 or 8? Okay, now you see these are there's a loop and there's a condition. So these are the checks actually. These are not some statement actually of the body. Okay, so that's not something that going to be displayed by default. Okay, it's a check that either we're going to do this or we don't have to do this. Okay, so that's why we don't need to plug any semicolon after that. Okay. Now to display, obviously, whenever the loop condition at line number 7 will be not true, so it will get out of the loop and it will come at line number 15. So we just write P at this stage and we don't put a semicolon, so it will be displayed. Okay. So once we do this, now let me just have a try to have a bigger view of the MATLAB because we just used our pseudocode. So let me just run this. So this, how you gonna run this? You will find editor here, go to the editor, and then run this. Now it will ask you to just store, uh, write some information. That is the name of the program you just made. So let me write basic bisection method. Okay. So I'm just writing basic bisection as a file name. Please, by the way, don't put a space in the name of your file. Okay. I have seen that it gives you an error. Okay. So if I just run this, you'll see, okay, here you see a command window. The output will be on the command window if it's not somewhere else you have wanted to go. For example, you wanted an Excel file or somewhere else you have importing information. But the basic display will be in the command window. So you see, we got a solution 0.739. Okay, and we know that this is the solution actually trying to have. And since we use a basic format, a by default format, so we have a view up to the 4 decimal places. In total, we have a 5 decimal places display. Okay, so but 4 decimal after the after the decimal point. Okay, so this is how we're able to get a solution so quickly with the use of the MATLAB. Okay, so just wanted to uh, conclude this particular lecture. So in this particular lecture, we are able to have some basic commands of the MATLAB. And you can, by the way, go to the chapter 1 of your book and you'll see many more basic commands of the MATLAB that you can go and practice. And yeah, also we're able to apply a pseudocode that we have developed into the MATLAB and see a solution uh, of the x minus cos x equation through the bisection method. Okay. So I'm going to share this working with you after our second lecture, okay, when we have made this bisection method more comprehensive. Okay, so thank you so much. Now, if obviously there will be some errors on your screens, uh, we're going to just discuss it after this lecture. Okay. So thank you so much. If you have any question regarding this, actually, I'm going to come to you and solve the problem if you're occurring any. Um, have most of you have done this? Yeah. So thank you so much. Thank you so much. We just able to learn the basic commands of the MATLAB in this particular lecture and develop the basic bisection method. Thank you so much.